Hey there, dirt bike people. I'm Chuck from Tuareg, and today I'm going to revalve and respring, otherwise set up the forks on this Tuareg 660. Now, these forks are notoriously terrible, and I've seen actual manufacturing flaws inside of them. I don't know if they're all that way or if some of them have it set up properly, but there are some major problems with these forks, and I will address them all, and I'll show you exactly how to do it. So the first problem with these forks is that they are massively undersprung, and that is a super common problem with adventure bikes. You can assume that if you have an adventure bike or a dual sport bike, it's undersprung. The problem with an undersprung bike is that the fork dives down into the travel, the rake angle gets too steep, it gets twitchy, and it actually ends up feeling harsh because you're riding so far down in the stroke and you're into that bottoming zone. So a lot of times what I hear is customers come in and complain that their adventure bike is feeling harsh and it's bottoming, and the first thing to look at in that case is fork springs. The second problem is that they are extremely underdamped, so there's almost no compression damping in these and in almost every other adventure bike as well. That makes the fork feel really wallowy and divey. It contributes to that low front end feeling. It contributes to that really squirrely feel, that unstable feel. And it also makes the front end bounce around when it hits rocks if there is insufficient compression damping. Rebound damping is also usually very fast. There's almost no rebound damping, so the front wheel returns too fast. It makes the whole thing oscillate. Overall, just really, really badly set up. Now you might ask, why are adventure bikes set up so poorly? And why would the manufacturers do such a thing? Well, the answer is quite simple, and the answer is not meant to be insulting. It's just that this bike is a street bike with a little bit more suspension travel, and it is set up for riders that are used to riding on the street and maybe doing a little bit of gravel. They're set up for people who don't know how to ride off-road. And to be fair, that is the majority of adventure riders. They're set up for comfort, not performance. Now, fortunately, there are several relatively simple things we can do to set these bikes up so that they are extremely capable off-road. And by extension, they will be much safer if we do these simple modifications. And like I mentioned, forks on almost every single adventure bike are set up in a way that I consider flat out dangerous. Now, incidentally, if you fall into the category of rider that has never spent significant time riding off-road, or if you're coming to adventure riding from an on-road background, there are specific courses that are being developed right now targeted at those types of riders. One that I've been directly involved with is the Traction eRag's XTADV, and I can personally say that it's an excellent course where we put riders that are used to riding big bikes on little Honda 250s, basically to learn trial skills, and then they transfer those skills from a little bike to a big bike. So riding adventure from a street perspective is very dangerous. Riding adventure from a dirt bike perspective is really tame. If you want to become a more competent, skilled, and ultimately safer rider, take some dirt bike training. If you want a discount code for the Traction eRag's XTADV course, click the link below. If you're interested in doing this modification or a similar one to your adventure bike and you want a little bit of guidance and coaching, feel free to join the Tuareg community. It's $7 a month. I'll put a link in the description below. I don't have time to respond to DMs and comments very much anymore. I'm diverting my communication efforts to the Tuareg community. I'll be actively involved in there. So if you have questions about this, that's a way to get a hold of me directly. Now for this part, I'm quickly just going to blow these apart. I'm not going to do a huge amount of detail with this, so I can spend a larger percentage of the video talking about the actual valving and how to do the internal modifications. Pull the cap up. So right off the bat, you can see a problem here. This is a progressive spring, which means that it has parts of it that are soft, which is this top bit here where the coils are tight, and parts of it that are stiffer, like down here where the coils are further apart. A progressive spring usually means that there's a lot of sag, and it really contributes to that saggy front end, unstable, twitchy feel of the bike. We're gonna get rid of that for sure. We're gonna pull down this plastic collar here and expose this nut, which is a 14 mil. I think we're 19. Yeah. You don't want to turn on the cap because the cap is actually separate from this top nut here. Turning on the cap can damage the threads internally. Cap comes off. I'll just put it on the bench over here. Then this plastic piece, then this poor excuse for a spring. Now I'll get down here, undo this bottom nut. Ooh, this one was really easy. It's often very helpful to use an impact for this. Now this bottom bolt usually provides some resistance. It doesn't want to come out. Oftentimes it's very easy to turn because the whole cartridge inside is spinning. So you can grab it on top. Sorry, I know you can't really see me grabbing it. There we go. Now this whole cartridge can come out, and that is what we are after. I'm going to do my best to bleed most of that oil out of there before I remove it. Now, if you're changing the seals, you want to continue on with that procedure. And if you're not changing the seals, you can just put that aside. Now, the other fork is identical. Now, of course, most of you are probably not going to have a fancy fork vise like this. It's okay. This cap should not be very tight. If you don't have a fork vise, I recommend that you loosen off these fork caps before you take the forks out of the bike. Loosen off the top triple clamps, keep the bottom ones tight, crack this loose, give it a couple of turns, then remove the fork. That way you can turn this out easily. Oh. All right, so I just spun off the spring spacer. That doesn't very often happen. Fair enough. I use my electric one because it turns a little quicker. All right, every now and again, I have to use my special tool that I made for this. It's a pain in the nuts. I'm sure I could get that out if I keep fighting with it, but I'm wasting my time. So this tool is gonna go down there. It basically sits in there and I'll be able to hold this and that'll solve the problem. I don't know if this tool exists anywhere else. I'm sure somebody else has made one. This tool was made for the older YZ250s. They're a little bit different. Because this is way down in there, I'm just going to get a wedge and stick it between there so it can't turn. I'm just going to use this chisel because it is a fat chisel and that will just prevent it from turning, and then I'll be able to... What a pain. This fork sure looks like it's basically the same design as what was on like a 1999 YZ250, which was, by today's standards, a very poor design. All right. Now, like I say, I could keep fighting with this, and if you just give it pressure and sometimes a little bit of heat, that bolt will come out. So I rarely have to use this tool, but I guess for the purposes of this video, it's good that I did have to use it. That's what it looks like. If you have a milling machine and a lathe, you can make one. Now, this fork is in charge of the rebound damping, and the other one is in charge of compression damping. So technically, you should keep them separate. You probably want to keep track of them. The other one already came apart, but I'll show you how to do it on this one. You just wind this nut off. It's very simple. And you take this spacer off. Now we're over here in the vise. We'll just be here for a second. We have to get this off of here. This is part of the hydro stop. It goes down into the cone, and when you're bottoming out, fork oil is inside that cone, and this forces it out and slows it down. It's swaged around a little clip here, so we just gotta basically bust that off. Just do this gently, and you'll just bend this little lip away. Now there's a little circlip here. Careful, don't lose this circlip. It's very small. Now this part of the hydro stop can come off. We need that out of the way. Now we need to pull this bottom nut out. Now since we're gonna put this upside down, you wanna pull this rod out of here. Might as well do that to the other fork too. All right, well this is where my special tool comes in handy again. Here you can see it locks into there. Now I can spin this nut out. So here you can see that is something of a base valve, and that one does the rebound. Now what we can do is push this whole damper rod out. There we have what's called a mid valve, and that is what we're going to be modifying. Beware, there is a spring. This is the top out spring. It goes there. You can put that with the cartridge. Now we're going to go do the same thing to the other leg. Now here you can see I've got the other leg in my vise, and this does not have a base valve. So we'll take these apart now and get into some details. All right, I've got all the parts cleaned up and degreased on the bench. You want to do that because you're going to be handling a bunch of small little parts. Now I'm just going to hold this. Take this nut off. You want to be careful with this nut. It's got peening on the end of it. The Japanese like to do that. Be gentle with that peening, and you can work it off slowly. Now I could just do this in the lathe, and and that would be technically better, but this works just fine. You just got to be gentle with it. So I'm going to show you guys how to do it without a lathe. You can see that peening just fell off of there. I'm going to lay this out in order. That little cap, spring, and then a shim. Now this often happens. This little thing doesn't want to come off, and the valve won't want to come off either. So we're going to have to file this down a little bit. File that burr off. Don't file backwards like this, or else you'll screw up your threads. These are the compression shims. I'm going to take them off as a stack with their limiting washer. Now this one is finished. Now we'll do essentially the same thing to this side. For some reason the Japanese are always trying to keep you from messing with their terrible designs. I'm going to take this whole rebound stack off. The valve. Now we've got one compression washer, and then over here we also have a spring and a little cap. So let's zoom in here a little bit and see what we're dealing with. This is from here. This is essentially, well, this is a thick washer. This is essentially a check valve. When oil flows through these ports here, comes out these bigger holes, it pushes on this check valve. The check valve is very easy to move away. So it just lifts out of the way and allows the oil to flow through there and creates almost no damping. So that's compression on this side. On this side, we have a little bit of a stack, but there's no spring, and these washers sit right against that valve. So this valve is providing some compression damping, but it's a very, very primitive design. Now, if you look at this, we have a similar design as this check valve, just this side is doing it for rebound. See, we have a thick washer here, and then a spring and one of these perforated washers. So as soon as this is on the upstroke, so rebound stroke, oil flows through here, the check valve moves away and provides no rebound damping, or almost no rebound damping. Now on this side, we have a little rebound stack here, quite pitiful, but it is doing something. So essentially what we have is this side is doing a little bit of compression damping and no rebound damping, and this side is doing a little bit of rebound damping, but no compression damping. On this side, this base valve is non-existent, literally, and on this side, there is a small bit of rebound dampening happening here. See, there's holes here, the oil flows up through there, and it will deflect these shims a little bit. So this is probably providing almost as much rebound damping as this mid valve is over here. Now that we understand that, let's get this apart and see what we can do to make it better. So in theory, what you would want to do is just make more damping with what we have here. The problem is that these components are so incredibly tiny that if we add too much damping, we're going to create a vacuum, and the vacuum is going to result in cavitation. Cavitation is when the vacuum is strong enough on a fluid that it vaporizes, and basically what you'll get is bubbles in the oil, and as soon as you have bubbles in the oil, your damping goes away. So to give you an idea, this is a typical base valve compared with this. So the amount of oil that flows through here, and this one is also pretty restrictive. You gotta think we can't add too much damping to this because it's just not physically big enough to accommodate it. This is a modern mid valve, although it is also a bit of a restrictive one. You can see the difference there. The amount of oil that this will flow allows us to get more creative with our shim stack and therefore more damping potential. What you can also see here is this mid valve has somewhat of a check valve, but there's also a stack in there. This is called mid valve float. If the compression damping was just like this rebound damping, right here, with no float at all, float being the distance that these shims move away from the valve, we would get a very harsh feel initially. So over small little bumps, you want this mid-valve stack to float away so that the oil can move freely, and that gives you plushness. And this is from an enduro fork, quite a soft one. Once this float has reached its maximum, when the shaft speed becomes such that this moves away really quickly, it tops out here, and then these shims are allowed to flex and they provide more damping yet. This float number here is very critical for the way that the fork feels, and after that we want to create a progressive stack. What I'd like to do is kind of mimic this one just on a smaller scale to these. This particular fork doesn't have the manufacturing flaw that many of them do. Many of them are missing this little collar, and they have a shim with a 6mm ID instead of an 8mm, and it's just bolted against here, so they have essentially no float, only one shim, and this shim is thinner and it gets distorted because there's no float, and the oil forcing through bends and distorts that shim, and sometimes they can break. So this one doesn't have that problem. If yours has that problem, you can fix it by putting in these components. Now what we do have here is the ability to build a system where we have damping on both sides, and that is going to allow us to take full advantage of the damping potential that we have in this system. And fortunately, we have all the components here that we need to do it. This one, we can put this back together. Now, we're not going to use this. This is our check valve, and instead of using a check valve, we're going to create a little shim stack. This shim stack on the other side is like this. Now, I don't care too much about this shim stack, but what we have here is this is a face shim, meaning that it sits against the face of the valve like this. Then we have a crossover, and that crossover allows this face shim to flutter independent of the rest of the stack. So then we have two more shims that are the same size. Yep, they're the same size. And then we have a clamping shim, and this is a thick shim. It sits against there, and it clamps the stack together. And the size of this clamping shim has a drastic effect on the movement of the entire stack, because if this clamping shim was bigger, it would allow less movement across the whole stack. If it's smaller, it allows more movement. So the clamping shim is really important. Now, what I am confident of is that this stack is not overwhelming the flow rate of this valve. So I'm going to stiffen up this stack and then mimic it on this side. Before I do that, however, keep in mind that this side has no float. They use this spring as the check valve. So what I'm going to do is flip this thing around, and instead of having a check valve over here, I'm going to build a mid valve with float on the compression side, and that's going to give me more rebound damping on this side. It's going to give me progressive compression damping on this side, and it is also going to add compression on this side. So we're getting more of everything that we want. So I've got a bunch of shims here off of my wall. Now I need to go from a 6 mil ID here to an 8 mil to accommodate this spacer, which is going to go here. 3 face shims. So basically what I'm doing is just removing that crossover. These are 16 by 0.1, sorry. This will be 14 by 0.1, this one, which is a 10. Now I'm going to do the same thing on this side. I am not a suspension expert. There are certainly better setups that one could ask for. This is super generic. I have almost no testing time on one of these Tuaregs. This is just me taking what I know of suspension and applying it. The bright side is that it's really hard to do worse than what was here stock. Now what we need is a washer to back up this shim stack here. Basically it needs to create a platform for this spring and for the shim stack to sit against. So I have one here. I'm going to go find another one. So I found something here. This is the same size shim. It's a 17 mil OD. I want a float of probably 1.2 to 1.5 millimeters. That's just my experience. And by the looks of things, I'm not too far off there. Yeah, look at that. I've pretty much nailed it. So I have 23 thou and 24 thou, which is 45 thou, so just over a millimeter. I have a little bit of room there. I'm going to say that is good. In case you didn't notice, what I did was flip this valve around. This should be the same. Yep. Now I'm going to set up a rebound stack. Now I don't want the rebound to be too slow, and I do run the risk of having that happen. So first thing I'm going to do is just have a look at what I'm dealing with the stock rebound on this side. So that's quite a rebound stack. I think if I do 2 of those, it'll be too slow. See, we have 1, 2, 3, 4, 5, 6 face shims. Then we have a crossover and then a progressive stack, also of 0.1s. So I'm going to change this. We're going to do 3 face shims. So now we need, and this should be 16 mil. Yep, 16 by 1, which is right here. 14 by 1. I think I have one of those on my wall. 14 by 0.1. Sorry, when I say 14 by 1, I mean 14 by 0.1. Actually, you know what? I think I don't want to go too stiff. I'm going to go 16 right down to 12. I am going to go with an 8 mil clamper. So we have got our rebound stacks. Now I'm going to be using this with 5-weight oil. This is quite a traditional setup for an enduro fork, although very soft for an enduro fork. We will see how this goes. It's not going to take me long at all to figure out if my rebound is too slow. I'm going to use my stopper. I'm a little worried about the rebound being too slow, so I'm going to add some more shims on the back side of the clamping shim. So I've got some more clamping shims here. We're going to increase it to just over 0.55. A little bit of Loctite on this nut. Now, something to consider is that we're going to go significantly stiffer on our springs as well. When you do that, you need to compensate with slower rebound damping or more rebound damping to slow things down, because that stiff spring is going to shoot that fork out a lot quicker. So faster rebound up to a point generally is going to give you more control. It's going to keep the wheel on the ground more of the time, but it does make things feel a little bit livelier in the front end generally. Sometimes it's unnerving, right? You always want to check and make sure that your compression stack is moving properly. You got good float, and that's looking nice. Now, one problem that we have yet to deal with is the fact that on this side, this cap only comes to here, and it is not going to plug up those holes. On the other side, the point is that this valve goes up past those holes, and any oil that comes, well, essentially the oil is just going to come in. That oil is going to be restricted by this valve. If we don't do something about these holes, everything that I just did with that mid valve is going to be useless, because the oil is just going to take the path of least resistance and go through those holes. Now, fortunately, this valve comes nowhere near those holes, so I think it's going to be too much if I cover up all 4 of those holes, but I think I can get away with covering up 3 of them, judging by the amount of resistance that this valve is providing. So I think one of these is going to be something like equal to all of these. Now, there is absolutely no reason to get you very close to my welding, because I am not a welder at all. However, I do have a little welder. I'm just going to weld these holes shut. There we go. Clean that up a bit. And we're back. Like I say, I am not a welder, but that will certainly do the trick. I've left one hole free here, cleaned up those threads a little bit. You gotta be careful when you're welding that. Anytime you're cutting or welding or grinding or anything inside of a fork, you want to make sure that it is absolutely clean. I took a fair bit of time to just clean this up. Now, don't forget your top out spring here, and you can reassemble the cartridges. Now, this base valve obviously goes in the one with all 4 holes. A lot of fancy cartridge kits that you can buy online are going to be much less suitable for almost every type of ADV riding that exists. In most cases, a cartridge kit is going to be harsher, and it's going to be more like an enduro bike, and most adventure riders don't end up liking that. So if you're somebody that is coming at off-road riding from a street perspective, you probably are not going to like a cartridge kit. And this is probably much more suitable. And it's cheaper, so that's an added bonus. I'm going to add this little clip. There we are. Now we're going to re-swage these. And remember, the majority of the force on this is this way. This little swaging just keeps this from sliding around on here. So it's not super critical, and it doesn't have to hold a lot of force. I've got my little assembly clamped in here. I'm just going to take a regular old screwdriver and my regular little hammer. I'm just going to swage that back in there. All I'm doing is retaining that clip. It doesn't take much. Voila! So I have changed the seals between these tubes, so it's all ready to go. Decided not to film that. You guys have probably seen that a bunch of times. I'm sure I'll do it a bunch more. Now this spacer and the nut, the rod. Now I'll be putting this back together with my impact. I know my impact really well. If you don't know your impact very well, look at the torque spec. Again, you'll probably have to hold this. Now before I put oil in here, I'm going to check on the spring length. I know that I'm going to be short, so I'm going to put spacers in to make up the difference. Standard procedure. So I've got the fork extended all the way, and I know that the fork spring is going to come up and sit against that spot right there. So I'm just going to hold this. I'm just going to use a regular old ruler. So I have a gap of 16 millimeters, and I want 5 millimeters of preload, so I want a 21 millimeter spacer. I've got some material here. I'm just going to cut that down to 21 millimeters on the lathe, and I'll be good to go. So I've got my little spacers. I'm going to pull this back apart. Now, if possible, I'd like to do this at the bottom so that I don't mess with any of the spacers up top, and I see no reason why that would be a problem. I'm just going to verify no problem there. That'll just sit inside. And I'm just going to drop that spacer in, And now I can dump in my oil. I'm gonna fill the oil to the top of the outer tube and then bleed it. And then I'm gonna suck out the excess to set my level. Grab this damper rod, I'm gonna stroke it a bunch. I wanna get all the air out of there. Oh yeah, I can feel that rebound. I really like it. After you've rebuilt a lot of sets of forks, you can kind of tell what the damping is gonna be like, and I like what I'm feeling. Need to add a little bit of fork oil, and I'm gonna set my fork oil level. Tool, yep, 130. You don't need a fancy tool. You can just use a syringe. Now I'm going to drop in my spring. Now my little spacer. Oh, no, that's not gonna work. I forgot that the stock springs have a taper at the top. Okay, no problem, found a solution. I've got a metal washer here that's just a little bit bigger than this spacer, and that is going to solve the problem. It's only gonna add 1 millimeter of preload. I'm using a spring rate of 6.5, so 0.65 kilograms per millimeter, and I have done this before. Terry from Stadium helped me do the math. So if you're anywhere from about 180 to 200 pounds, 0.65 kilograms per millimeter is a good spring rate. There we go. I won't bore you with doing it again. The other one is exactly the same. 130 mils oil height, 5-weight oil. That damping was feeling really good. I'm gonna test ride it tomorrow, let you know how it feels.